Hello and welcome to the open house session for the preparation course in AP Physics C Mechanics. My name is Dr. Kuchina. I will be your instructor for the class. I have my two doctorate degrees in physics, and I started learning physics when I was about 10, 12 years old. Since then, I was in universities, in research institutions, and at some point I decided to return to people uh, whatever I have learned. And since then, I'm teaching physics at different levels in high school, in community college, which is 2 year school that ends with associate degree, and at 4 year institutions that you can gain your bachelor's degree from. I love physics because it's a very playful discipline, and especially in mechanics, you have opportunity to observe everything in real life, to learn from your observations, and to make connections between different observations to conclude or progress your knowledge a little bit further. I'm glad that you are interested not in just physics, but in calculus-based physics, which means you're also savvy in math, and math is a language of science, and physics specifically. Math and physics, if you look at the history of physics, every physicist had to have a good mathematical background, and every mathematician at Newtonian times was trying to apply math to solving some physical problems. What physics study? Oh, you know that you have completed the course, right, in your school, or you're currently enrolled in this course, and I hope that as we go and prepare for the exam, you will be wrapping up your course. So by the time we are covering this session, you already have all the instructions. So you had your lecture and you come to this session to practice problem solving, to get comfortable with the type of questions that this exam asks, and to get the answer to the question that typically bug students. Why didn't I get point for this answer? What was wrong with my answer? So that's what we will be doing. AP Physics C exam in mechanics is not considered easy or hard. It is an exam that requires knowledge of calculus. And as students that are studying calculus before you graduate school, you are very advanced in your mathematical skills, in your logical skills. So the success rate at this exam is higher than in different physics exam, AP Physics 1, in my opinion, is due to overall maturity of students in AP Physics C courses, because you had more preparation. More preparation means better suitable to solve problems, right? The exam itself consists of multiple choice questions and free response questions. And it influences your grade both 50-50. What we will do in every session, we will try to solve some multiple choice questions and select the correct answer, and we will practice free response questions. That's the area where most of the students lose their points. The reason for losing points could be multiple, and not knowing the material is obviously one of them, but not the single one. You may spend too much time answering multiple choice questions, and that kind of delayed you into, um, you know, focusing on free response questions. Or you're tied so much from the first part of the exam that you can think clearly through the second one. Whatever the reason, we want to be prepared and we want to practice and take this exam take the sample problems from the previous year's exams, to be aware of what to expect, and when the certain question is asked, how to answer this question. As you know, most of the questions involve numbers, so you will be using calculator. You don't need to have a fancy graphing calculator. If you have it, it's okay. But I believe the best way and allowed to the test are basic scientific calculator, that's for sure. Graphing calculator could be used, but you still need to plot your graphs on the paper if a graph is required for the problem solving. Also supplied with each exam is formula list. I want you to be prepared and print out one of them so we can use them every time we do problems on certain topics. And the reason for that, I want you to be prepared to use your resources when you're on exam, right? When we're nervous, we not always think straight, and we can forget simple things. Having a formula list is for your benefits. You can always, turn your pages, look at the formula list, and remind or refresh your knowledge of the formula to make sure that you didn't forget the correct sign or correct exponent of the variable. So those things should be always with you for each class. Also, to each class, to each session, I want you to bring ample of scratch paper so we can solve problems on the paper. You will be given time to do so. And what will help tremendously is if you have, your laptop has a touch screen, and you can participate in the class by writing on the screen using annotate function of the Zoom, or use a tablet with a pen. I don't have a touch screen. I'm using tablet, and I'm writing on this tablet to explain my line of thought. Not everything can be printed, right? So paper, pencils, ruler, tablet, or touch screen, and calculator are a must for each session. The better you prepare, the better you will feel, the more comfortable you will feel during the session. Typically, the score distribution is kind of shifted towards better score. Again, as you see in here, about a third of all the students get score of 5. That's remarkable. That means that not only you understand math, but you understand physics much better than than in different disciplines. So it's one of the highest here, right? Maybe only calculus has a higher score. And that's, again, some of the reasons for that is that while you were studying calculus, you already covered some of the topics in physics. So you took this course already twice in calculus, then in physics, and now as a refresher in this class. Please be ready to use your knowledge of calculus, to use your knowledge of physics, and show off it in this class. That's a challenging test, but obviously doable. And you're in this class to make it happen. And your active participation, your interest in succeeding in each session determines how well you will be doing on the test. You have 2 parts of each exam. The first part is multiple choice questions, and it takes 45 minutes. to answer, and it will be a set of questions. Sometimes it's a set of questions, sometimes it's individual questions, and again, you will be presented to the type of questions that were previously asked on the exams in this class. So you will see what is typically asked. And then you have a free response question, the same time and the same amount of score. In here, you will need to know how to answer. So circling the answer is one thing, right? Even if you don't know the answer, finding something that seems to be the most possible answer, probable answer, is kind of guessing work. And while having 5 answers minimizes your success in guessing, you still can get lucky and get a good score there. In free response question, we're looking at your answer, how to formulate your answers, what to write and what to skip. That's what we will be doing and practicing in this class. And I wanted to, I will model it for you, and I want you to practice and do that over and over again as you prepare for, as we move on with next topics in this course. We always will have an opportunity, and that's what earns you points, is justification of your answer. Saying the object will go left is not enough. Well, it will earn you 1 point, but then you will have an opportunity to justify your answer. And based on your justification, you can earn more points. So when you justify your answer, you have to practice what's called CER method. C stands for claim, E for evidence, and R for reasoning. And honestly, if you will use CER method in every argument that you take, you will do so much better. And I hope you do that every time. So we will practice this as well in this class. And typically it involves equations, graphs, calculations. That will be form of evidence that you will use. So your evidence could be in words, in graphs, in formulas, things like that. Okay. And being specific is another quality that helps you to earn better points, because sometimes it will be up to you to discuss the behavior of the function, and that involves the variable. So you can justify your overall claim to begin with. The class will last for 12 weeks. We'll have 1 week spring break, but other than that, we will have 7 units. And in my opinion, the most challenging unit of all of them is rotation. Rotational dynamic and kinematics, while it's very closely repeating our understanding of kinematics and dynamics in translational motion, somehow for students it could be a very difficult topic to wrap their head around. But I'm glad that it's not at the very end of the course, and I hope that in your classes you will cover it before coming to the session for rotation. And we will talk about that, talk about similarities and what could help you to quickly assess the answer. But by far the most inclusive unit will be oscillations, because oscillation is not only about kinematics, it's also about Newtonian laws of motion. It will be about energy, it will be about power translated with waves and oscillations. It will be about momentum, about rotation. All of that will be included in oscillation. So it's kind of summary chapter. And gravitation unit is maybe my favorite because it's very historical and leap forward in physics as a science. That proves to be developing and still maybe waiting for new step to be developed in gravitation. So it's kind of application, both oscillations and gravitation is applications of all this knowledge to the real world phenomena that we will study in this. Thanks. So when you sign up for the class, somewhere early next week, you will get an invitation to join the Canvas. And when you open your Canvas shell, you will see a page like that. For you to join the session, to join the questions and answers session, you will have to click on Join Your Class Live. In a proper time, you just click and you will join our session where we will discuss. I will ask you to keep your camera on and active participate in every discussion that we take. I will ask you questions, you will ask me questions. Let's make most of it. Asking questions is the best way of learning, and when students are very silent, you know, if it's an open house, I understand you came here for a demonstration or something, but if you came to study and you don't have any questions and you don't have any answers, that's a troubling sign. It means you're not actively engaged. So I want to minimize that. Okay. So below this Join Your Class Live, you see the highlighted area that this class will be available until the end of July. So long after the class will be over and long after your test will be administered. So you can always come back and use your resources to refresh this or that topic. As you click on one of the weeks, and you will have 12 weeks here below this Join Your Class link, you will get to the typical structure of each week. Week 1, just like week 2, 3, and 12, we'll have handout. That will be PowerPoint that is used, just like I used this one for the open house. This PowerPoint would not substitute for the session. You absolutely have to come and participate in it, but it could help your memories to refresh what we were talking and what were important points of solving this or that problem. Then you will have homework, and homework, just like test, will consist of 2 questions, of 2 parts. One part will be multiple choice questions, and you will be answering it and getting it graded automatically right away. So immediate response. The second part will be free response question. And free response questions, I will be looking at and grading it. You will not get a separate grade for free response questions, but after looking at your work, I will point out what were the strong points in your answers, what was insufficient, where we need to improve. And then the last link will be to the recording. I doubt that you will use it too much, but if for some reason you missed the session, you can always watch the recording. And it also helps to rewatch it just in case you forgot what we were talking about, or what was the important point that steered us in one direction and not in another. Because when you don't know how to solve the problem, every opportunity seems to be equally possible, right? How do we select one direction to go after? That will be covered in this section. And let's look at an example. I hope that you recognize this incline problem on incline. This one is a simple question 1, and it talks about two masses, M1 and M2, that are connected by a rope hanging from a pulley on an incline, as shown on the picture. If the coefficient of kinetic friction between M1 and the plane is mu A, kinetic coefficient of friction, what is the magnitude of the acceleration of the two masses? And assume that M2 is accelerating downward. So this question could be equally a multiple choice question or free response question. And if it's just the multiple choice question, you will have to quickly assess everything, but the procedure of solving the question is always the same. You start with the main hearers of the problem. What is the object of our interest? And in this case, we have two of them, block M1 and block M2. So you will concentrate on both blocks here. You will be concentrating on M1 and on block M2, right? Now, what is the next step? Because they're asking about acceleration of the block, what do we know? What defines acceleration of the block? It's dynamics, right? We are talking about friction. What other forces are acting on the block? So we'll look at block M1, and we identify objects that are touching the object. So, for example, a rope, right? The rope will create force. What do we call this force? We call it tension, right? Now, what is another force that is acting on this block? It's touching the surface, so there will be a normal force and there will be a friction. My overall acceleration is downward, right? So my acceleration is downward. Which means the friction will be opposite to acceleration. So that's my normal force. And my friction will be in upward direction. So I will add another vector of force. Oops. Another blue force of friction. Another force of friction. And it's kinetic friction because block is moving. Any other forces that we know of? Nothing else is touching. So string gives you tension. Touch with the surface gives you normal and friction. The last one that we will mention will be gravity force. So we will identify gravity force. And we will use Newton's second law to write it down, to correlate some of all the forces with acceleration, right? So we will write something like, let me see. We will see, oh, in this case, we have two-dimensional patterns, so we need also the axis, right? Coordinate axis. So one of them will be axis X that points down. And the axis Y typically points up, right? So that will be my Y-axis. And now we will use two components, X and Y, to record the second Newton rule. So we will start with X. We have 1, 2, 3, 4 forces. 4 forces looking for X component for each of them. We will be needing this angle. Do we know what this angle is? How would we know? I have two opportunities. I can build a right triangle here, right? So if I look at this big triangle, then this, what color we will do? Magenta angle will be complementary to this angle, right? If I, so that will be 90 minus theta. And if I continue this one, I will have a smaller triangle, and that's a right triangle again. That's a vertical and that's a horizontal. So it's another right triangle. So it will be complementary to theta. So that will be a theta angle. Okay, that will help us to find our X and Y components, right? So our X component will be opposite to the angle, so it will be defined through sine function, and our Y component will be in negative direction, and it will be adjacent to the angle, so defined through the cosine. Let's write it down. Radio naught. So in X direction, what do we have? We can start with normal force. Normal force has zero component. It's all in positive Y direction. So 0 is for normal force. For tension, it's all in negative X direction, full magnitude of the tension. What about friction? It's also in negative X direction. And finally, fourth force is gravity, and it's in positive direction. And it's a magnitude mg, right? But we're looking at X component only, which is opposite to the given angles. So we will use sine of angle theta. That will be sum of all my forces, or net force. So it will be proportional, and it's mass 1. That will be proportional to mass 1 and acceleration. Acceleration is positive, and I see that it's positive in here. In Y component, T and friction, tension and friction have 0 component, and normal has full magnitude. So normal is full magnitude, tension has 0, friction has 0, and gravity will have negative. It's looking down, so it's negative m1 g cosine alpha. It is true that if you correctly define your trigonometric function for X component, the Y component is simply using alternative trigonometric function, sine, cosine, change places. Do I have any motion in Y direction? No, I'm staying at the same level here. So I'm not accelerating in y direction, so it will be equal to 0. And that will be all the equations that we have for the M1 block. M2 is moving vertically. If M1 is sliding down, my block M2 will go up with the same acceleration because they are connected to each other. So it will be accelerated upward as well, right? So what are the forces? I see only one attachment, so that's the tension. And in this case, my tension will be the same as tension on the block M1. So I can use my tension here. And another force that will be acting will be force of gravity, M2G. And here it was M1G. So I will have only y component for the block M2, and it will be positive direction will be upward in the direction of acceleration. So we will have tension minus M2G, no component, no cosine or sine is needed, and it will be equal M2A, right? So we don't know tension. What do we know about friction? Kinetic friction, we also know that kinetic friction is defined as coefficient of kinetic friction times normal force. And normal force could be found from this equation. So from here, I see that normal force equals M1G cosine theta. So that will be what I will put in here, M1G cosine theta. And now, tension is what I don't know and really don't need to know. I'm hunting after acceleration, but there is a trick on how to get rid of tension. If I add two equations, the first and the third one, in the first equation, the tension comes as negative, and the third is positive. Adding them together will yield 0. So I can do addition of all this together. What would I get? I will start with a positive term. I will have M1G sine theta. I took care of this one. Negative friction, so I will re-record what I have here. I already defined my friction here. So I took care of this. I subtract this one and I subtract and add this one. What's left in here is add M2, negative M2G. What I have on the right side is sum of masses, M1 plus M2 times acceleration. So how do we solve equation for the variable like A? Well, we already did a lot of work here. All that's left to be done is divide all this expression by the sum of the masses. So that's what I will do. And another thing that I can do is I can notice that I have factor G in each of these equations. So I can factor it out, write down the remaining one, M1 sine theta minus mu k M1 cosine theta minus M2. I recorded this whole part, and now I will divide it by M1 plus M2, and that will solve my problem. If numbers are given to you, you will plug it in after you created this equation. So steps are very standard. Once you know which way you have to go, that will be a very straightforward solution. You always will have on the handouts, you will always have a solution that is clearly written to you on the next slide. So any questions with my handwriting will be figured out. You see that it's not finalized, but it's enough information for you to complete the solution, right? Let's look at one more problem. As shown in figure 4.3, a mass m is dropped from height h above the equilibrium position of a string. Set up the equation that determines the spring compression d when the object is instantaneously at rest. So how much it has to be compressed to get to the lowest point, the biggest compression of the spring. Do we have to consider forces here? What we say is it's at rest, so motion matters. It says height, so height matters. And it says spring and compression. All these terms are typically telling us that if we're not considering any accelerations or nothing in kinematics and no questions about forces, probably we have to use energy approach, right? And what energy approach tells us? Energy approach tells us that if we consider total energy, total mechanical energy at the beginning, and that's your before drop in mass, what kind of energy do we have in here? The object is at rest. So for mechanical energy, I need kinetic energy and I need potential energy. I will put initial. With this energy, if I have any non-conservative forces, I need to add force work done by other forces, non-conservative forces. And then after that, I will have to add final kinetic energy and final potential energy. And when we're talking about kinetic and potential energy could be gravitational and could be elastic. Do we remember formulas for that? Look at your formula list. Your gravitational energy is proportional to the weight of the object, mass times gravity acceleration times height. And your elastic energy, potential energy, is proportional to the spring constant and your compression, right? So that's the general formulas. Let's look at our formula and see, do we have any non-conservative forces acting in here? Our block is initially in a free fall, then it experiences slowing down by the spring. Spring is elastic force, which is conservative force. No other forces are acting, no jets, nothing like that. So we don't really need work of other, right? The object is dropped, so it's released from rest, so initial energy is 0. And at the very end, when the spring is compressed, the object is instantaneously at rest. So kinetic energy final is also 0. So let's look at the rest of the formula. Now we're balancing our potential energies, right? So initially, gravitational potential energy, I would say, if I will call this a 0 point, my origin point, right? Initially, my gravitational potential energy is mgh because I height h above the origin. And my spring has 0 energy initially because it's relaxed. It's not compressed. At the very end, I see that my block is now a distance d below origin, so it will have gravitational energy of negative mgd. And now my spring is compressed, and energy of the spring will be proportional to the compression, which is amount of d. Now they ask to set up the equation that determines the spring compression, so I need to solve for d. How do I solve for d? I need to get rid of this factor, right? I will put it on the other side. Add mgd to both sides. On the left side, I can factor out mg, and h plus d will be there. That's not good, right? Because d is my variable, and I have quadratic equation in this case, so it won't be solved. So, no, that's not the solution. I need to use my quadratic equation solving steps to find the equation. So I write down the quadratic equation. Let's look at this. My 1/2 kd squared is my quadratic term. Then I have negative mgd, my linear term of d. And then I have negative mgh. That's my free term, right? That equals to 0. So I know that that's my A. This one is my B. And this one is my C. So I can solve for D using the quadratic formula. Negative B, so B is negative mg, negative B will be simply mg. Plus or minus B squared, so I will have mg squared minus 4 times A times C. And I put a big square root in there and divide by 2a. So 2 times 1/2 k. These two will cancel out, right? What do I have in here? I can solve it. So I have negative and negative, they cancel out, right? And my d will be mg plus or minus mg m squared g squared plus 2 k m g h and divided by k. Now, if I look under the square root, the result of this square root will be greater than mg. And if I subtract the number that is greater, my distance of compression will become negative. I already used the negative sign as a directional sign in here. So that should be a positive number, right? So negative sign should be excluded, and only one of the solutions will be the correct solution for this problem. And you can see the same way of solving it, not to the end, but you will have to solve it on your own. Now, multiple choice question. No, it's not multiple, it's multiple question. A mass is dragged distance delta x along a rough surface by a force F applied at an angle of elevation theta, as shown in the picture. The coefficient of friction is mu. What is the net force on the block? What is the net work done on the block? What is the work done by friction? And what is the work done by the applied force? And you will use the same steps as we did in first question, identifying the forces. So because force is applied to the right, you would expect that the object will be moving to the right mostly, and the forces that will be acting will be, the friction will be acting to the left, the normal up, and gravity is down. So I will be looking into each individual force and their components in here, right? To find the net force on the block. Would the normal force be equal to mg? No, because your force, applied force, is taking some of the load from the normal force. So it will be slightly less than gravity. Again, you will set up the equations to find the answer to each of these questions. But we will practice it to answer each and every of these questions. Do you have any questions for me? I want you to be, when you come to the class, I want you to be prepared to ask questions. I love questions, and we all can benefit from discussions more than we can benefit from just listening to someone. I want you all to give it a try, to volunteer to solve it on the board. Do you have any questions? I want to say that I really appreciate that you're taking this course. It shows that you take your education seriously, and I feel that, you know, people who didn't take physics are not fully educated, because physics is so much about learning about our nature, and without this literacy, we're missing a lot. It's not that we're less people, but a lot of adventures are lost in unknown. I hope that we will uncover a lot of interesting things as we